Hello and welcome everyone. This is Mohammad Izamam from SAIMEDHA ECET Coaching Center Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing a golden opportunity to all the ECET 2024 and as well as ECET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, SAIMEDHA Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే SAIMEDHA Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous ECET examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ SAIMEDHA Koti, Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ECET examination questions with which you can understand the level of teaching, the expertise which is there in the SAIMEDHA Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ECET 2024 and ECET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Now I'm explaining question number 16, 2013 question. The characteristic impedance of a transmission line depends on option 1 shape of the conductor, option 2 surface treatment of conductor, option 3 conductivity of the material, option 4 geometrical configuration of the conductor. Here characteristic impedance Z0 is equals to formula under root of R plus j omega L divided by G plus j omega C. G plus j omega C. So R is resistance, L is inductance, G is conductance, C is capacitance. All these four parameters are known as primary constants and these primary constants can be explained by using the geometrical configuration of the conductor. That means the length of the conductor, the cross sectional area of the, all these geometrical configuration will be discussed when we are explaining these primary constants. So the characteristic impedance of a transmission line depends on geometrical configuration of the conductors. So option 4 is the correct answer. Next question, question number 17. This is 2015 question. The reflection coefficient on a transmission line is given as K is equals to 0.25 angle 45 degrees. This is the reflection coefficient value is given. We know that reflection coefficient is a vector quantity. Here in our question, reflection coefficient is expressed in polar form. That means magnitude as well as phase. Then is asking standing wave ratio. So standing wave ratio, to determine standing wave ratio by using reflection coefficient, we are considering magnitude of reflection coefficient only, that is 1 plus mod k by 1 minus mod k. 1 plus mod k by 1 minus mod k. Here what is the magnitude of reflection coefficient means mod k value is given as 0.25. 0.25 that I am writing as 25 by 100. 0.25 I am writing 25 by 100, that equal to how much? 1 by 4. Reflection coefficient magnitude how much? 1 by 4. Then standing wave ratio SWR equals to, I am writing 1 plus 1 by 4 divided by 1 minus 1 by 4. That equal to 4 plus 1, 5 by 4 divided by 4 minus 1, 3 by 4. That equals to 5 by 4 into 4 by 3. 4 cancel, 5 by 3 means 3 1 ja 3, 3 1 ja 3, 2 3 6 ja 18. 1.6 is the correct answer. Option 4 is the answer. So when the reflection coefficient value is 0.25, then standing wave ratio is value how much? 1.67. Option 4 is correct answer. Next question, question number 18. In a lossless transmission line, the propagation constant is. So, in transmission line, propagation constant gamma equal to formula in terms of primary constants under root of r plus j omega L, under root of r plus j omega L into g plus j omega c. This is propagation constant formula. And what is the units of propagation constant? Per meter. Now is asking the propagation constant value in a lossless transmission line. The condition of lossless transmission line, is what? R equal to 0 and G equal to 0. When R equal to 0 and G equal to 0, then transmission line is said to be lossless. Now I am substituting R equal to 0, G equal to 0, then propagation constant becomes as j omega into under root of LC. This is propagation constant value when the transmission line is lossless. So here option 3 is the correct answer, j omega into root LC. Next question number 19. This is also 2015 question. Intrinsic propagation constant of a medium. So when electromagnetic wave we are explaining in a medium, there are three medium parameters are there in electromagnetic waves. One is sigma, conductivity, epsilon, permittivity, mu, permeability. These three are known as medium parameters in electromagnetic waves. So when electromagnetic wave is traveling in a medium, to explain the wave characteristics, we are using these three medium parameters. By using these three medium parameters, propagation constant of a medium formula is gamma is equals to under root of j omega mu into sigma plus j omega epsilon. This is propagation constant formula using medium parameters in a medium. So j omega mu into sigma plus j omega epsilon means option 1 is the correct answer. Yes. Next question. Question number 20. If voltage standing wave ratio is 3, then the magnitude of reflection coefficient is. So till now we calculated standing wave ratio by using reflection coefficient. Now this question is, if you know standing wave ratio, how you determine reflection coefficient? So here generally when standing wave ratio is given, then we are finding only magnitude of reflection coefficient only. Remember that point. So by using standing wave ratio, we can determine magnitude of reflection coefficient only. Here magnitude of reflection coefficient means mod k, that equals to formula standing wave ratio SWR minus 1 by SWR standing wave ratio plus 1. This is the formula SWR minus 1 by SWR plus 1. So what is the standing wave ratio value is given in our question? Voltage standing wave ratio value is given as 3. So reflection coefficient, magnitude of reflection coefficient equal to 3 minus 1 by 3 plus 1. 3 minus 1 is 2, 3 plus 1 is 4, 2 by 4 means 1 by 2. What is the value? 1 by 2 only given. Answer is 0.5, but option 2 is given as 1 by 2. Hence option 2 is correct. Correct. What is the value of 1 by 2? 0.5. Why I am calculating like this? Because reflection coefficient value always lies between 0 and 1. Question number 21. A transmission line is terminated by its characteristic impedance, then the resultant input impedance is. So this question is 2015 question. This is transmission line having secondary constant Z0 characteristic impedance. If it is terminated by again what? Its characteristic impedance means the terminating impedance I am representing with ZR, sometimes it is representing with ZL also. Now I am writing ZR. What is the ZR value is given in question? Z0. So when ZR is equals to Z0, then the input impedance is answer already we calculated, that is equals to its characteristic impedance. So when the transmission line is terminated by its characteristic impedance, then the input impedance Zi is equals to its characteristic impedance. Zi equals to Z0. So option 4 is correct answer. Next question number 22. For a transmission line at a high frequency region, generally transmission lines are used in low frequency region only, because when the transmission lines are used in high frequency region, the attenuation constant is also depends on frequency. Previously distortionless transmission line we discussed. In distortionless transmission line, what is the condition? Attenuation constant is independent of frequency and phase constant is linearly dependent on frequency. But when the transmission lines are used in high frequency region, then attenuation constant is also depends on frequency, then losses will be existing. So here the question is, when transmission lines are used in high frequency region, attenuation constant alpha also depends on frequency. When it depends on frequency, what happens? Losses will be exist. That's why transmission lines are always used in low frequency region only. But here the correct answer related question is option 1 is the correct answer. Next question. In a mismatched transmission line, that means what? Standing waves will be existing. Mismatched, Zr is not equal to Z0. So mismatched transmission line means what is the condition? Zr is not equal to Z0. So he is asking the voltage node and nearest current node. See here, I am considering voltage waveform like this. This is the voltage waveform if you consider like this, and this is maximum values, these are minimum values, voltage waveform I am considering. So the distance between these two, or the distance between these two is what? Lambda by 2. Here also what? Lambda by 2. But is asking the voltage node and the nearest current node are separated by. So suppose I am considering this is voltage waveform and one more waveform I am considering like current waveform. This is I am considering current waveform like this. See here. So if it is voltage, this is current, if you assume, what is the distance between these two? Lambda by 4. What is the distance between these two? Lambda by 4. Hence the correct answer is what? Lambda by 4 is the correct answer. So remember, standing waves will be existing when the transmission line is mismatched. Then we are considering the standing waves waveform in terms of voltage and current. Then the distance between two successive voltages or two successive currents is what? Lambda by 2. But here is asking the distance between a voltage node and nearest current node is how much? Lambda by 4. Option 3 is the correct answer. Next question 24. Condition for distortionless transmission line. Here distortionless transmission line, this is the asking. So a transmission line is said to be distortionless. A transmission line is said to be distortionless if an attenuation constant, what is the symbol of attenuation constant? Alpha. If attenuation constant is independent of frequency and phase constant linearly dependent on frequency. This is the definition of distortionless transmission line. Attenuation constant is independent of frequency, phase constant is linearly dependent on frequency. So in this condition, what is the distortionless condition means? R by L equal to G by C, or RC equals to LG. RC equals to what? LG. R by L equal to G by C, or RC equals to LG, or here R by L, okay, RC equal to LG. So RC equal to LG is there. Option 2 is the Correct answer. R by L equal to G by C. Remember, that means what? RC equal to LG. Next question, question number 25. The range of voltage standing wave ratio is. So, to determine the standing wave ratio value, I am considering three cases. This is Z0 and this is ZR. So, ZR equal to Z0 case 1, ZR equal to 0 case 2, ZR equal to infinity case 3. ZR equal to infinity means what? Open circuited. ZR equal to infinity means what? Open circuited. ZR equals to 0 means what? Short circuited. And ZR is equals to Z0. ZR is equals to Z0 means what? Perfectly matched. So, in these three cases, see here, when ZR equal to Z0, K equal to 0. And ZR minus Z0, what is the K formula here? ZR minus Z0 divided by ZR plus Z0. So, when ZR equal to 0, K becomes minus 1. When ZR equal to infinity, K becomes plus 1. So, if I consider magnitude of K only, then K value 1. That's why reflection coefficient value lies between 0 and 1. So, when reflection coefficient is 0, then standing wave ratio becomes 1. And when reflection coefficient is 1, then standing wave ratio becomes infinity. When reflection coefficient is 0, what is the formula standing wave ratio in terms of reflection coefficient? SWR is equals to 1 plus mod K by 1 minus mod K. So, here reflection coefficient when it is 1, then standing wave ratio is infinity. When reflection coefficient is 0, then standing wave ratio is 1. So, from these two cases, the range of standing wave ratio is 1 to infinity. What is the range of standing wave ratio? That is 1 to infinity. Standing wave ratio range is 1 to infinity. Option 3 is the correct answer.
So, my dear students, for ECET 2024 and ECET 2025, SAIMEDHA KOTI Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi SAIMEDHA KOTI Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద SAIMEDHA KOTI Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.